In this section, we'll talk about some good strategies to use for solving these traveling salesman problems with the use of our knowledge of Hamilton circuits and Hamilton paths. Alright, here's strategy one, exhaustive search. It's basically what it sounds like. You're just going to make a list of all the possible circuits, and for each one you're going to calculate the total weight. From all the circuits, choose the circuit with the smallest total weight. Okay, and we don't have the time, at least in this video, to work out every single one, but I'll show you how it's been done at least. So notice how if we start at A and go A, sorry, not that way, where's B? B is over here. A, B, C, D, E, and then back to A. So we take all those weights and we add them up here. That comes out to be 812. If you notice, some of the other answers are a little bit better than that. So that's when you'd be like, okay, well, we'll erase that. We'll try it again. And the next one, we'll switch things up a little bit. So A to B to C. Instead of DE, we can do E, D, and then back to A. So we still hit all five, just in a different order. And that way it came out to be a little bit cheaper. All right. And we have 5 vertices, so with 5, if you remember back from the chart a couple sections ago, that's 5 minus 1, yeah, 5 minus 1 factorial. That's going to tell us how many distinct paths there are. There's 4, so that's 4 factorial, and that equals 24. So there are 24 distinct paths, but notice there's only 12 listed here. That's because the mirror paths will cost pretty much the same as the original. So, for example, looking at the last one here, number 12, A, D, C, B, E, A, it's just opposite over here on the right. A, E, B, C, D, A. So it's just the original backwards. It's still going to cost the same. So we're lucky in this case we don't have to calculate for all 24 because each one has its own mirror image. Notice now that after doing all of them, though, that the one with the least total weight is the 11th try here, where it came out to be 676. So it's just a game of luck. You keep going until you find the cheapest one. Typically, yes, you're going to have to list out all of them because you don't want to miss one that could have been the cheapest one. This takes a long time to do, but it is one way to ensure that you can get the optimal route. Alright, strategy 2, go cheap. It's a little more, it's a little better time-wise. So we're going to start from the home city, and from there you're going to go to the city that is just the cheapest to get to. So it's kind of like an improvising strategy. From each new city to go to the next city, from each new city, go to the next city that is cheapest to get to. When there are no more new cities to go back home. Okay, and here's the example with the solution worked out, but I'm going to draw on top of the graph to show you how this can be done, at least on the graph. So we're starting at A, and if we look around, A to E is 133, A to D is 152, A to C is 119, and A to B is 185. So A to C is definitely our cheapest option. We're going to go with that. So we can't go back to A until the very end, until there's no other places to go to. So now we're either looking at, from C, we're going to go either to B, D, or E. So we only have 3 choices here. So C to B is 121, C to E is 120, and C to D is 174. We are going to go to E, because that is the cheapest. And then from E, now we can either go to D or to B. So to D is 199 and to B is 200. So we're going to be choosing D. And at this point, we can either go to B for 150 or A to 152, but we can't really go back to A because we need to hit all the vertices. So in this case, we're lucky that DB was cheaper. Now, if D to A had been cheaper than D to B, we still would have had to take D to B to make the complete tour. So we're going to go D to B. It's really our last option. And then now we're really left with no choice. We have to go directly back to A. We cannot go to any of the other vertices. So notice that B to C and B to just B to C and B to D are much cheaper than B to A, but that's what we're left with. So we're going to go that 185 route back to A. We add all those up, we get $773. So we got 600 and something when we did the exhaustive search. So yeah, it costs a little bit more, but look at how much time we save just by doing it that way. So it depends on what you consider to be more valuable, time or money. Alright, here's another example. We've got a tour of 10 cities starting at A. This one's pretty crazy. I'm not going to attempt to put all the numbers on the graph. It's going to get really messy. So we can solve this one by doing the chart. So if I'm starting at A, let's look across the row and let's find the city that or the site that has the smallest value. So it looks like for this one it's going to be C. So A to C. Well, we started with A. I'm going to circle that. So we'll mark out C. So A to C. And then from C, and we can't go from C to A, so that's done. So from C, I'm looking on the I'm looking right here now. From C, let's look to see what the cheapest option is. So we can't go from C to C, obviously. So from C to B is 121, C to D is 174. I'm looking across this third row right now. It looks like our cheapest option is going to be from C to E. Okay, so now E is done. Okay, and we're starting with E now. So from E, we're going to look and see what our cheapest option here is. So 133 for A, 200 B. It looks like our cheapest option is going to be the 120 to C. But, okay, here's the problem. We can't go back to C because it's already been used. So I'm going to mark that out actually. And let's mark, well, we can't go back to E. And we could go back to A. I mean, it is the cheapest. However, if we go back to A, we're reusing it before we go to all the others, so that can't be used as well. So the next cheapest option here is going to be the 199. Okay, that's what we're going to have to go with, E to D. So we've crossed out D. All right, now we're moving on. So from D, where are we going to go? I'm actually going to stop, and I'd like you to try to finish this on your own. We'll talk about this more in class. Okay, back to the satellite example here. Once again, I'll start from the beginning just a little bit, and then I'd like you to finish it yourself. So we're starting at Earth. Notice the satellite is on its way to site M over here, and that's actually not the cheapest, so we're going to start and go somewhere else. It looks like the shortest route is actually going to be straight over here to site C, Callisto. So we're going to take this, so let's write the values over here. So 3.1, and at this point we can either go down to site G 1.5, we can go to Titan over here for 5.6, 5.2 to Mimas, and 0.8 to Io. So this is definitely going to be our shortest route. Oh, wait a minute, let me write that vertically. Alright, and from Io, let's take that. We don't have as many options now. We just have 3 options before we have to go back to Earth. So we can either go down to G, we can go over to M, or we can go to T. And it looks like our cheapest option right now is going to be to go straight to G for 1.1. Okay, and again, just keep following this algorithm, keep following this cheapest route method, and see what you get, and add up all the numbers, and we'll talk about this more in class, but I'd like you to finish it on your own. Okay, here's the Mars example again. For the last time, I'll get you started, and again, I'd like you to finish it yourself. So with A, we're going to start, well, I guess we can really start anywhere, it doesn't matter that much. Why don't we start up here at N? So at N, let's look at row N. It looks like the shortest distance is going to be to go straight to I, which on the map, if you look at it, it looks like it makes a lot of sense. So we'll go to N to I. Alright, so we'll add them up over here, so 2,000. So we're done with I. Now look at row I. Where can we go at this point? Now, we can't go back to N, because that's our starting point. We can't go to I, and that's already marked out for us. So we really only have 5 other options. The cheapest of those options, or the shortest of those options, is going to be to go to A. Straight across here. Okay, so A is done. And from A, look in row A now. We can't go back to N, and we can't go back to I, because those have already been used. So, of the 4 options left, the cheapest is going to be to go to site P. Okay, and hopefully by now you're starting to see the pattern. What I'd like you to do is finish this on your own, and once again we'll talk about this one in class and see how you did with it. Take your numbers and add them up at the very end, see what your total is.